Are you good on number 1, or do we need to do number 1? You're good on number 1, so you should have gotten C. Okay, good. And then, so let me do number 2. Just I want to write it out so that you can see what it looks like. So probability that x is less than 8 is what we're looking for, right? So if I write it in words, this would be the probability that it's not orange on 7 consecutive draws, I think is what they called it. So the probability that it was orange was 22 out of 50. So the probability that it's not orange is 28 out of 50, correct? And 7 consecutive draws, I would raise that to the 7th. But the question says, what is the probability that it will take less than 8 draws? So what I've just done is the complement. So I need to do 1 minus 28 over 50 to the 7th power, and that is 0.983. Got it? Got it. Okay, so number 3. The heights of married men are approximately normally distributed with a mean of 70 and a standard deviation of 3. Excuse me. While the heights of married women are approximately normally distributed with a mean of 65 and a standard deviation of 2.5. What's the probability that a randomly selected married woman is taller than the married man? You think that's going to be a high probability or a low probability? Low. I would expect that as well. Doesn't really help you eliminate any choices because those are all kind of low probabilities. But so what I did first is, since they told me that it was normally distributed, I just kind of set the problem up. So it's a normal distribution for men with a mean of 70 and a standard deviation of 3. And then it's a normal distribution for women with a mean of 65 and a standard deviation of 2.5. And if you were doing a free response question on an AP exam, you might even want to go so far as to say, let W equal heights of women, let M equal heights of men, before you started with your notations, just to be clear, okay? So what I'm really trying to figure out is this: women minus men greater than 0. What's the probability that the women height minus the men's height would be greater than 0? Okay, so I need to do the expected value of women's heights minus men's heights. So the expected value of, well, actually I'm not even going to call it X. I'm going to call it what it is, women minus men. Okay, well, what's the mean for the women's height? 65, right? What's the mean of the men's height? And what is the expected value? -5. Got it. Okay. Then it says, I need the, I know it doesn't say that I have to get these things, but I'm going to need them to actually answer the question. So if I get the expected value, I'm probably also going to need to get the what? Yes. You know where I'm going with this? Normal distribution, z-scores. In order to determine probability, z equals x value minus the mean over the standard deviation. This ring a bell? From Chapter 6. Okay, so if I want to find the standard deviation of women minus men, Pythagorean theorem of statistics says that you can't subtract them. Even though I'm finding the difference, I need to just add them. So I'm going to square the 3 and square the 2.5. And when I do that, I'm going to get 3.9. You might want to check my math just to be sure. So she's got, okay. So now, this would actually be a great AP question, like a free response question. So now that I've done this, I actually have a normal model of women minus men, which looks like what? -5, 3.9. That's what my model looks like now. Okay. Well, it wants to know the probability that a randomly selected married woman is taller than a randomly selected married man. So I need a z-score. This is really easy with a z-score. So come over here and go z equals 0. Good. Well, it's going to be minus -5, which is plus 5 over 3.9. I believe that is 1.28. You can double check me again. Okay. How do you find probability with the normal distribution? Normal C, D, F. All right, my lower limit, 1.28. My upper limit can just be like 999. And you should get 0.10, which is answer choice B. Good. That was my next question. If you just wanted to do it with the mean and standard deviation, what's the calculator command? There you go. You don't have to calculate the z-score. You could do lower limit, upper limit, mean, standard deviation. But if you convert it to a z-score, then all you have to do is lower limit, upper limit. It was good practice for us to do the z-score, though. I need to be greater than that. Remember we said this up here? So that's kind of like our target x. Aren't you glad you're in here? Right? Okay, so let's try number 4. 65% of all divorce cases cite incompatibility as the underlying reason. If 4 couples file for divorce, what's the probability that exactly 2 will state incompatibility as the reason? So the first thing that we need to do is run through our different distributions to determine which one we should be using. Now, did it state anything about it being normally distributed? Not really. Is it one of those where it says, until we get a success? All right, so do I have a set number of trials? I do. And this puts it at what distribution? Binomial. Yes, Ephraim's happy. Okay, so what's the command? Binom PDF, because it said exactly. Okay, so the command is N, P, and then X, right? And so N in this case is 4. The probability of success, that's what P is 0.65, and X is 2. And I believe you get 0.3105, which is choice D. I know. It's nice to have the update so that you don't have to remember what the commands are. You know what you could do, though, before you actually take the exam, you can make sure that your calculator has an updated operating system. You can just share operating systems, like with the linking cables. Okay, number 5. Oh, number 5 is too easy for us to do together. What do you do on number 5? Expected value. Okay, well, I just want to do it because I want to make sure you're setting the table up right. And I'm leaving it right here to see what you're going to put. It says if the probability of having a boy or girl is equally likely, determine the expected number of boys. So let X equal the number of boys. Remember on your quiz, the very first question says, what is the random variable? Okay, in this case, the random variable is the number of boys. So we set up a table, and because we used x, we're going to use x here. All right, well, how many boys could I have? 0, 1, 2, and 3. Yeah, you can have kids and have no boys. Yeah, no. Now we got to do the probabilities. You're right. Okay, so what is the probability of having no boys? If you have no boys, it means you have one girl, and that probability is 0.5. Okay. So now let's talk about how you would get one boy. So that would be 1/2 times 1/2, which is 0.25. Okay, so now I'm going to have, because it says that they have 3 kids. They got to have 3 kids. Well, until they have a boy, right? So what about 2? So it's 1/2 times 1/2 times 1/2, which is 0.125. And then what about 3? Same thing. They're only having 3 kids. Okay, now what should we double check before we leave our probability distribution? Add it all up, make sure it equals 1. Got it. Okay, and then it says, what's the expected value? What is if the probability determine the expected number of boys? So that's just list 1 would be the x's, list 2 would be the y's, multiply list 1 times list 2, and then find the, what? Find the sum. List 1 times list 2 equals 0.875. Now, can I convert that to a percent? No, it's expected value of the number of boys, so this is a discrete value. So it's not something I can move the decimal and turn it into a percent. Okay? All right, so number 6, we just have to go through here and pick out which ones are true and which ones are false. So it says, which of the following are true statements about probability density functions? The histogram of a binomial distribution with p equals 0.5 is always symmetric. That is true. The histogram of a binomial distribution with p equals 0.9 is skewed to the right. It is going to be skewed, but it would be skewed to the left. That is correct. If the probability of success is way over here, then the data must be over here. And remember, another word for skew is pulled. That's just your probability of success. That doesn't mean that's not where all your successes are probably going to be in a binomial distribution. So do you remember the day that I gave you the notes on the binomial distribution and I gave you the criteria and we even talked about where the probability distribution, where the histogram, how it would be shaped? This is an example of that. All right, the histogram of a geometric distribution is always decreasing. That's true. That's a true statement. So this is good that we're going over this because the first one and the third one are true facts. The second one. if the probability of success is high, then it would be skewed left. If the probability of success is low, then it would be skewed right. So the answer to number 6 is B. Okay, number 7. A probability experiment involves a series of identical independent trials with 2 outcomes, a success or failure per trial, and the probability of success on each trial 0.1. Determine the number of trials in a binomial experiment such that the expected number of successes in that binomial experiment will be equal to the expected number of trials in a geometric experiment. What? I know, right? So here's what I've got. NP, do you recall seeing NP? Mean of a binomial distribution equal to 1 over P. Where'd you see that? The mean of a geometric distribution. And they want them to be equal. And then it says the probability of success on both is what? It gave it to us in the stem of the problem, 0.1. So n times 0.1 is equal to 1 over